Okay, real quick video here to introduce kind of another side of a coin that we've already been learning about. We're talking about parallel lines throughout this unit. What we've learned so far is if we know that two parallel lines are cut by a transversal. So remember, that's our river and our bridge, right? The transversal is the bridge. The important thing to note here is that we specifically have to be given that these lines are parallel. These relationships don't actually apply if the lines aren't parallel. So I've got lines like this, if I've got like a really ugly river and I got like this wonky bridge cutting across it, these relationships are not going to apply. So specifically, we have to have parallel lines for these relationships to work. Now, something I've kind of brushed over, just so you guys are aware in this picture, these little triangles right here and right here, those are little markings that tell us those lines are parallel. So if we don't see those markings, we can't assume that they are parallel. We have to see those little triangles, and what they mean is they're kind of like arrows, actually. They point in the same direction. That's what parallel lines do. They point in the same direction. So here's what we've learned so far. If two parallel lines are cut by a transversal, then let's review this. You guys have to know this by now. Oh my gosh. Corresponding alternate interior and alternate exterior all have the same type of special relationship. What is it? It is congruent. They're equal. Corresponding alternate interior, alternate exteriors are equal. Consecutive interior and whoops, my bad, consecutive exterior angles, sorry. Both the consecutives are what? Supplementary. They add to 180. You have to have those relationships either memorized or written in a nice, easily accessible place in your notes because you can reference that during your test. So here's what we know again. If two parallel lines are cut by a transversal, then these relationships are true. What we're looking at today is something called a converse theorem. Now go ahead and copy this. If we want to prove that two lines are parallel, so we don't actually know that they're parallel. If the proof says R parallel to S or something like that, we use what's called a converse theorem. And again, please make sure you have that copied down. Now, what a converse theorem does is it flips the if and then parts of the statement. So again, if we look back, and I'll show you again here, I had if and then. In geometry, we have a lot of statements like this. They're actually literally called if-then statements. If this is true, then this is true. If this is true, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So this is, again, what we've learned so far. Here's parallel lines, therefore these relationships are true. What a converse theorem does, again, is it flips these statements and creates a still true statement. So here's my two statements. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. The converse of this theorem is going to make those two little pieces of my sentence switch places. So we're going to copy this next piece down as well. So this is an example of a converse theorem. And all of the relationship theorems are going to read like this as well. So notice the corresponding angles are congruent came after then in that sentence, and now it comes after if. If corresponding angles are congruent, then we have the first part now coming second. Then the two lines cut by a transversal are parallel. So again, a converse statement, you want to have this copied down. A converse statement flips the two parts. Yeah. But it still creates a true statement. Not everything works this way. I can't flip every single if-then statement and it still be true, but this is. If this relationship applies, if corresponding angles are congruent, then we do have parallel lines. So I'm not going to have you copy every single one down, but the alternate interior angles, converse theorem, would read the same way. If alternate interior angles are congruent, then the two lines are parallel. So these are, again, a converse theorem versus just our regular theorems. Now, once more, we're going to do a little example here. The reason why we need to use converse theorems is if our proof is lines are parallel. If our proof is prove that these two lines are parallel. So let's go look at an example. Okay. So as an example here, we are given these angles are congruent. So we are told angle 3 is congruent to angle 7. Notice our prove is, are these lines parallel? So make a note to yourself if you need to, write it down to emphasize. We know we will use a converse theorem if they say prove and then lines are parallel. This is V parallel to W. So what we need to do then is, again, it's going to be the same thing. It's based on the relationships of the angles given to us. We are given angle 3 is congruent to angle 7. And again, our first reason is always given. Notice that is our given. So let's look at angle 3 and 7 in the picture. Here's angle 3 and here's angle 7. They're telling us they're equal. Now that's good because they have a special relationship when, if my lines are parallel, they would be equal. So what is the name of the relationship between 3 and 7? They are alternate interior angles. Now, because I want to prove lines parallel, my reason is not just going to be, oh, they're alternate interior angles. We are going to say alternate interior angles converse theorem. If I want to prove lines are parallel, we use a converse. And that's because it's stated like this. If alternate interior angles are congruent, then lines are parallel. It goes in the order of our proof. We have that alternate interior angles are congruent, and therefore the lines are parallel. That's the converse theorems. Let's try another one. Okay, so we are given again some information, and we want to prove V parallel to W. Once again, kind of hint for the future. If my last statement is parallel lines, our reason will be a converse theorem. So given as always first, let's go ahead and go through this. We are given angle 2 is 145. Here's angle 2. And then angle 4 is also 145. And then we can say that the measure of angle 2 equals measure of angle 4. Now, again, we are eventually going to say the relationship between them. However, we're just going from 1 to 2. So we're not saying the relationship yet. That's going to be our last reason. Our last reason will be the relationship converse theorem. So let's see if you can recall this. They both equal 145. If two things equal the same thing, those two things are equal as well. What is the name of this property? Transitive. This is transitive property. This is what you did in the quizzes. If two kids have the same grade and then this kid has the same grade as the other, well, the first one and the last one, they also have the same grade. This is transitive property. If two things equal the same thing, those two things are also equal. So now that we have proven they are equal, that's good because we need to show that angles are either equal or supplementary based on their relationship. So let's look at their relationship here. Angle 2 and angle 4. So because we proved them equal, that's good because the name of this relationship has equal angles when lines are parallel. So what is the name of the relationship between angle 2 and angle 4? It is corresponding angles converse is what we want to say. Now I'm kind of skimming over a couple things here, guys. Postulate and theorem, don't worry too much about that. Sometimes we use postulate, sometimes we use theorem. It just means something that is true, that we have shown to be true. So don't worry if you're leaving off postulate or theorem. In your test, that'll already be written for you and you just need to choose it. You're not going to have to write it out yourself. So once more, here's what we had. We were given that these angles happen to equal the same degree. We said, oh, well, because they equal the same degree, that means we can say this, they're equal by the transitive property. And then we said, great, because they're equal and corresponding angles, that's why these lines are parallel. The corresponding angles converse theorem states that. So we're going to do a lot more complicated ones in class, but I wanted to give you guys a little bit of a taste of understanding the difference between converse theorems and just our plain old theorems and how we know when to use each.